Here's the prototype of the tone plan generator chip. This is an Atmega 328P. I was developing it on an actual Arduino, but I transferred it over onto a standalone chip. So instead of an Arduino, it's kind of a cost-reduced version that has the 28-pin chip. It's got a crystal that runs at 16 megahertz, two capacitors that load the crystal down properly for proper oscillation. It's got a resistor that ties the reset pin to high for power on reset. And on the output, I have it in the ground referenced unbalanced mode. So the output comes out of a single pin and it goes through a one-stage LC low-pass filter. So this filters out all of the 40 kilohertz harmonics from the clock frequency. And if you run this, as I am, off batteries or a very clean DC supply, the tones are really, really clean. There's no background noise or anything. You can't hear any clock noise out of the processor. And I'm rather surprised at how clean it is. The low-pass filter works really well, and it works better if you feed this into a high impedance input. So I think, even though the volume is pretty good, you probably would want a high impedance amplifier chip like an LM386 on the front end of this thing, just to provide a little buffering when connecting it into a switch. But I think it might work with just cap coupling. I've got a capacitor here on the output of the filter, so 1 microfarad electrolytic. And I think that might actually give enough volume to hook directly into the switch. So it kind of depends on what kind of transformer is being used and so forth. So there's plenty of pins here. I'm going to add some jumpers on here. And the thought now is to have two sets of jumpers. One selects the tone, which by default is continuous. And then there'll be another set of jumpers that select all of the common telephony cadences plus ring cadences. So I'll include the Bellcore ring cadences, and I went through notes on distance dialing back about 4 or 5 different editions back into the 50s, and I wrote down all of the different cadences that were used for reorder and so forth. So I'm including all of the tones mentioned in notes on distance dialing and all of the cadences that are documented there, plus a couple of additional ring cadences, including a UK ring cadence. So that's the plan right now. Right now, though, I just have the tone generator running a demo program that cycles through the additive and the modulated tones that I kind of figured out how to use. The synthesizer here can generate 4 simultaneous tones. So you can emulate a modulated tone like old dial tone or low tone, high tone maybe. Anyway, you can emulate that by mixing in a little bit of square wave and doing some other tricks with the 4 voices available. I've fixed it so the levels of the various tones are all pretty much equalized, so there's no volume increase on certain tones. And it seems to be working pretty well, so I'll just run through the cycle here real quick. So precise dial tone, precise ringback, old Western Electric earpiece. It will drive it directly to really loud volume. Okay, we have precise busy, precise reorder, modulated dial tone, modulated ringback, and a modulated alternated ringback with a slightly higher fundamental frequency. And modulated busy. And modulated reorder. And that's pretty much it on the tones I have in there now. Let me turn it off. There will be some additional ones a little bit later. So anyway, that's it. Just a quick look at what the circuit entails. It's really simple to build, and it sounds quite good.